就是他们听不到你在说什么，所以他们就会安静下来，然后听你在说什么。
And good night.
Clearly, it doesn't work.
什么？对，他会有那种。对。Are you gonna start? When do we start recording? When do we start?
这个给我。这个 work。
这个它的 work。
Right. Welcome to day 2 of Halves. Yeah? We have, I believe, 4 teams today. So teams will have 15 minutes to explain their progress up to this point, talk about their plans for the rest of the semester. So I'll be keeping the time, so watch me for that, and then you'll have about 5 minutes for questions from the faculty and the audience. So with that, I believe Sync Night, you're up first.
Thank you. Good afternoon, everyone. We are Team Sync Night. Up on the stage are our team members, and we have Mo and Heather as our project instructors. Heather is also our client, and William is our sound designer, and Brad is our subject matter expertise from Epic Games. Our presentation covers project overview, progress update, and future plan. As for project overview, I don't know if any of you have heard of Fortnite concert before, but I will give you a brief introduction of past events in Fortnite. So people showed up in virtually online and in real time in Fortnite, and they join concerts usually one time or during a specific period of time. This is the first Fortnite virtual concerts that held by Marshmello in 2019. As you can see, people are dancing on the dancing floor, followed with Marshmello's music. This is Karol G's concert. That's one of the latest Fortnite concerts, and it's held in 2024. As you can see, people are racing in a car, and there's a scoreboard indicating they are competing with each other, and they are followed to Karol G. Some of the aspects we found out from our research, and also some of the reasons why we want to create our project are: first, we think Fortnite creates a gaming multiplayer characteristics that people can join virtually online in real time. And second of all, we think there's an involvement in interactivity, as you can see from Marshmello's concert to Karol G's concert. And third of all, we think virtual concert will provide more opportunities for guests to interact with the artist. That concludes us to create our project, a multiplayer music concert experience within Fortnite, and we want to explore the full potential of its sound ecosystem and its gameplay integration. Our potential audience are concert goers and gamers, and our deliverables will be a public event after we have published on Fortnite, and it will be a replayable experience. And we will be creating our experience in UEFN.
Thank you. So, UEFN, huh? What's that? So, UEFN stands for Unreal Editor for Fortnite. According to Epic, it's here to empower creators to build experiences and publish them directly into Fortnite using the power of the Unreal Editor. So, what does that mean? To use UEFN as our game engine. How's that different from a standard Unreal Engine? They look pretty much the same. Do you guys want to hear the good things or the bad things first? Good? I knew it. Pros. First, it provides a number of built-in devices for us to craft our gameplay much more easily. And we can call their functions using words, which is the code language in this engine. For example, if you want a teleporter, you can just drag 2 portal devices into the scene, set their teleporter group, and they will do the work for you, which is very convenient. And also comes with several functions for us to connect it with other in-game elements. Another great benefit for using FN is that it allows us to use countless assets Epic has made, and they are modular. So a level designer can use them to easily build a scene without help from an artist. For our project, we easily find lots of music-related props, and they are used in our both design and game stage, which you'll see soon later. However, it also has weaknesses. In this engine, you might see a great shotgun, and you think it would be perfect if you can just change a little bit of its fire rate. No, you can't. And you might see a nice prop, and you think it would be, I just don't want it to play a sound. No, it has to. Or you want to modify the player? Well, as you can see, there are some options you can customize. But adding a new player action, just forget it. During the design process, I keep telling myself, design is constraint. And can you imagine living in the world without custom collision detection? In this engine, if you want to detect 2 objects collide and trigger an event, your life hangs on this bluish, harmless volume device. You have to bind it to an object and use this device to trigger on-enter event. Luckily, if you don't like a cube, you can make it a cylinder. Besides, you are also living in a world with no prefab, no state machine, no motion, etc. Again, design is constraint. Yeah. All these constraints require us to define our possibility space first. We need to keep doing technical exploration to understand its limits so that we can design around its weaknesses. Just like Epic promised on Unreal Fest, a lot of good things are on the way. And so I do believe that the very potential for future ETC projects, and it's definitely worth trying. But for this project, our team needs to be extra careful about our design decisions. And now I can proudly say design is constraint. So I'll let Yihua introduce our design part.
All right, thank you, Aaron. Next up, we're going to introduce our design part. Before that, we're going to show you a slice of our boss combat, which is our demo reel. All right, so that's it for the demo reel. Next up, I'm going to talk about our overall design. So our goal is to create a music experience, platforming obstacle courses, and a boss fight at the end. So some of you might want to ask, why a boss fight? Here are a few reasons. First, we want to enhance our player and environmental interactivity because previously Fortnite concerts focused more on the concert itself rather than having a lot of interactivity. So we want to create more interactivity with the player and the environment, meaning that a boss fight is our best way to go. Another one is to create an immersive synchronization experience, meaning that not only the player is going to fight the boss in sync with the beat of the music, the environmental props and the environment are also going to join in to create an immersive synchronization experience. Next up is design strategy. So we want to start with the boss fight first to actually define the core mechanics and actually have a really crystal clear vision of what we need to create for the previous obstacle courses. Like I mentioned, the boss fight serves as a accumulation of knowledge and skills the player have to learn along the way, along the courses previously. And in the end, we want to create a streamlined development so to keep everything go smoothly. Next up, Charlotte is going to talk about art.
All right, thank you, Yuhua. And for our art, we have this poster demonstrating the style and colors that we aimed for during the early stages. And we drew some storyboards to explore different possibilities for our gameplay perspective and our color palettes. And here is our concept design for our boss. It's a giant mechanical creature composed of various assets from our concept stage. In a concert stage, and we iterated to look more robotic with less human-like structures. And while we are making the model, just like what Aaron says before, we have plentiful and countless amount of art resources from UEFN Asset Store. Therefore, we found some concert-related assets such as speakers, concert pillars, LED screens, and wires, and so many different instruments. And we used 260 of these assets to build our boss. And our boss is so large that it spans 100 meters in the game. And for right now, we animated some basic movements for the laser stage of the boss fight. And we are continuing to refine the environments and animations. And next, Annie will be showing you all the visual effects.
Thanks, Charlotte. The boss emits fire beams from his hand, using fires and smoke, which are common elements in the concert, to set the mood. The VFX design also surrounds electricity, fitting the boss electronic components with a charging effect. The floor is textured after a real concert stage, enhancing the lightings. Manipulating particles in real time can be performance heavy, but a simple solution is to put 3 to 4 identical effects at the same location, activating one on each beat. Using the level sequencer, we are able to sync VFX with music. Here is a syncing example. The post-processing effects references concert lighting and retro video games that fit certain parts of our music. For performance testing, we have found that using multiple Niagara systems had little effect on FPS and response time. However, we found that using multiple post-processing volumes can cause delay. So we plan to merge effects to reduce calculations and limit their use to smaller areas. Also, since UEFN only supports forward rendering, we had to customize some features that are only available in standard Unreal Engine. Next, Arthur will talk about tech.
Thank you, Annie. So let's talk about tech design. Our main goal of this first half of the semester is to hack away out through all the limitations. Our work consists of exploring the UEFN ecosystem, see what we can work with, see what we can build with, and essentially build a workflow that we can continually iterate on our gameplay. One of the first things we created is this gym level. Essentially, it's an incubator for all the features that we want to put in the boss fight, put in the levels. We have put in, so far, the music-driven environments, music-driven platforming, music-driven VFXs, and some of the boss attacks. But how do we put some of these together? We're using patchworks. According to our SME says, they perfectly sync our music with gameplay together, majorly in these recurring events, such as the boss attacks, some of the sound effects, and mainly some of the features that we want the players to interact with, including the shooting mechanics that if player shoots on beat, you'll be getting a damage boost. But what if we want to make something more linear, more sequential? We want to make the players feel that the boss is interacting with them with different movesets. What do? This is the level sequencer that we're mainly using to drive all these functionalities together. What it can do is control almost every variable that you can do in the level, including the VFX, opening up the VFX, some of the plugins that we can use, including turning on the laser, or spinning around, have the boss do some of the attack animations. But with only level sequences, we cannot support an environment that has more interactivity. With interactivity, we need players to get feedbacks. How do the player get feedbacks? It's through essentially a state machine that we have hacked together to use triggers to ensure that the players will be getting different feedbacks as they're interacting with the boss. One of the other things really interesting is we built this workflow with the artists to make sure that they have more control over the boss as we're building in a level sequence. In the beginning, we have these 260 components in the game, but no way to drive it around. So we have created this skeletal mesh. Essentially, it means a mesh plus a rig that will be further building into a control rig, which is special. Which is special to Unreal Engine, that we're able to edit it within the level sequences. And this is so far what we built so that the artist can gain more control over the gameplay and more control over the boss animation throughout the levels. And as the journey so far, I believe that with more constraints, we have come up with a lot of hacks, and we're excited to see what we can bring you guys in the final round. Next up, let's talk about the future.
In terms of the future, we have researched, we have also done tech explore before our quarters, and we have finished our first stage of the boss. We'll be further develop our second stage of the boss and do more play tests while doing so. And for the final, we'll be doing a public event after we have published our project in Fortnite. And thank you all for coming, and we're open for questions and comments.
Yes, please.
Yeah, so typically a concert experience is really about featuring the performer in a really central way. Can you talk about how that fits in with what you're doing?
Yes. What we have in our vision is having the boss more as the performer. The boss will be playing different music. For example, in the laser stage, the synths kind of work as an attachment to the lasers to make sure that these aesthetics line up with the music itself. And as the player is moving on into later stages, you will see the boss turning into other forms and taking other forms of attacks, so that it feels like we want to create the feeling that the boss is performing the music as the player is playing through the experience. And about the question that we want about the question that we want the players to take more consideration into the boss as the could you repeat the question, please?
Yeah,
I'm trying to think through it.
You answered it partly. So it wasn't clear to me in the presentation that you had the kind of stand-in robot boss that would be representative of the performer. So that wasn't obvious to me. I think I get it. Another part I wonder about the most with it is a boss fight is usually about the boss has a life meter. I get it to a certain point. The boss changes modes. That can't happen here because the song is fixed. You can't have the boss be changing modes mid-song, probably. That sounds tricky. So you have to find ways around that. But anyway, I'm just trying to understand that more, because this notion of, let me just say it this way. I don't think with any of the virtual concert experiences before, has there been a situation where the players are oppositional, are fighting the performer, and that just opens a kind of host of challenging issues?
About that question, I think the feeling we want to create, now that I think about it, is more like a dance between the player and the boss. The boss is inviting the players in to essentially join this concert and dance with them. Although sometimes the encouragement to dance is if you don't dance with the boss, if you don't playing to the music, you'll take damage and you'll die. But about more of the, do you want to hear more about the technical part of how we are planning on implementing these features? Like how the boss is, let's say, switching phases and how it's different from the traditional concerts is we plan on having looping music for 15 seconds that consists of a boss's attack pattern. And if the players don't make through it, or if the players don't do enough damage, as the time goes on, it will automatically switch to the second stage.
So I think the thing that you don't know when the player defeat that boss, right? So it makes very tricky to transit the stage. But one thing we can do is that maybe let's say we need 2 bars, which are 8 bits to transit the from the stage 1 to stage 2 if the player defeated the boss at the first beat. So we will play an animation with last 7 beats, and it will smoothly transit to the next part of the music. If it hits beats that at the 5th beat, so we will play the animation for 3 beats, and it will seamlessly transit to the next stage of the music.
Do I have more questions? Yes.
Yeah.
So often in games you have a stage that leads up to the boss, right? And the stage is often the boss's territory, or in some ways it's related to the boss, right? And so the stage kind of builds up this anticipation that the boss is going to happen. You have this gym level. Is that connected to the boss in any way? Is there like a relationship between them, or I'm just trying to figure out how the two parts meet together.
The gym level, mainly what we're doing with the gym level is to stuff our prototypes into it so that our playtesters and plus the developers can play around in it.
Okay.
To see how if we're getting the game feel right, if we're getting the mechanics right, but it's not going to be related to the gameplay itself.
Okay, so the boss is kind of like a standalone thing.
Yes.
That's separate from the gym. Okay.
Yes.
Yeah.
Thank you.
That's time.
One more. Thank you.
So speaking as a musician performer, I'd hate it if my audience was trying to kill me. So, and you didn't talk much about play testing. I'm just curious, what is the audience feeling, and what would the musician be feeling at these experiences?
It is honestly a strange story we're trying to tell, that the audience join in on this strange, well, lethal party that the host is doing. But if we're really talking about the storyline, what we want to do is you have this. If anyone have watched Zima Blue from Love, Death, and Robots, we want to build this feeling of a boss is getting slowly torn apart into a, in the end, standalone as a, it's playing the same rhythm, but it's playing more like, it's from a more acoustic point of view that is playing the rhythm in that way. We're taking away the synths, we're taking the drums. In the end, it's just music itself. Pardon? Yes, we're testing these. Thank you.
Hello everyone, this is Team Pat. Here's a nice photo of us. Our instructors are Dave and Tom. So really brief introduction. We are making a toolkit that helps developers make action games. But how does that work? So imagine in this scenario where you are a game developer, which is true for some of you, and you're making this game with a complex platformer and combat system, but you don't know how to build everything from scratch. So naturally, you turn to toolkits you find in asset stores. You first come across this great platformer solution called Corgi Engine. But the problem with that is Corgi Engine supports little to none combat system, and this movement in Corgi is based on a very specific physics system. You can't just switch to another one. Then there's this melee combat system that can serve as your combat solution. But the problem with a lot of cool combat skills templates it provides is that those skills are intertwined with local motion, and so there's no way of you getting the two toolkits to work together. The reason you would run into those problems with toolkits out there is that they provide you ready-to-go systems that are not meant to be modified by users. What it means is that if the user wants to design their game to fit the toolkit and its pipeline, then the toolkit is super helpful, it's super efficient because it usually provides tons of built-in functionalities. But you just have to be super careful because the moment you start designing something that is out of scope for the toolkit, it'll be a nightmare, and you will hate yourself for not using Penguin Action Toolkit in the first place. What we do is that we're enabling users to modify our system and do their own thing. It's probably more fair to say that the target audience for the other toolkits and for us are different. We're aiming at developers with some experience and a lot of their own creative decisions and don't want to be limited by the package. On the other hand, if the user just wants to make their own Mario level, they should definitely go with Super Mario Maker. It's way easier that way. So how do we go and build this toolkit? We start with, this is our pipeline. We start with building the system, our code base. Then in order to find out whether we can make games out of the system, we make games. And through making game prototypes, we also find out the features required to actually make a game. So we add those features to the package. And the package will be delivered with tutorials and documentation as the final product to the users. And then we see how easy it is for users to create a game. So by quarters, we had a pretty good working system. Where do we go from there? We need to start making prototypes. But what kinds of prototypes will be useful to us since our project is not about making games, but about making a toolkit that makes games? The first prototype we did and showed you guys during quarters was this 3D demo with a purple rabbit on the moon. It goes to test two major pieces of action games, locomotion and combat, which are also the foundations of our features. Now, most of the other toolkits out there can make this. I mean, at least the good ones can, but it's still a really good starting point for us. We do believe that our second prototype needs to be different enough. We want it to be difficult to make with other toolkits. We wanted to demonstrate our flexibility, and we also wanted to serve some of our own internal testing purposes. So going back to the platformer plus combat example, a really interesting game that popped into mind was Castlevania, which is a 2D action adventure platformer game. We believe Castlevania is the one because, one, we wanted to serve some of our own testing purposes. We started the demo in 3D. We don't know if our system still works in 2D. And the other thing is, mechanics-wise, what makes Castlevania difficult to make, or what makes Castlevania Castlevania, is the result of a lot of game design choices that end up requiring a highly customizable locomotion and combat system. The examples we give here are demonstrations of that. So there are limitations to what you can do when you're using each different weapons. For the hammer one, you can never move and attack at the same time. Your attack always cancels movement, and then there's a short recovery window after each of your attacks. But with the weapon in the middle, you don't have this problem. You can always freely move and attack. And at some point in the game, you can turn into a bat and fly. So next, Jingyi and Harry will talk through how we make those specific things happen in our toolkit.
So from 3D to 2D, there are many modifications made to the basic gameplay logic, such as the camera and the locomotion. So you can see here from our first prototype, we have a basic 3D game template. The camera view is controlled by the mouse input, which, well, actually doesn't fit the 2D games. So after modifying the camera, the locomotion also needs to be iterated as the 2D character movement is only constrained in one X. So we also added some extra details onto the character. For example, the character is forced to finish a turn back to make sure there is no intermediate rotation status. And the character will be mirrored when turning to another direction so that the weapon is always held by the hand closer to the camera. So throughout the whole progress, we only modify the game using the interfaces that our users can access, and the underlying structural logic was not changed. And all these changes make the gameplay feel more like 2D. And by successfully implementing this, we validated that PAT does have a general locomotion solution which fits different kinds of games. Besides the basic game movement, such as the walk and the jump, we also implemented some special abilities from Castlevania, which are very closely related to specific locomotion changes. So this may not be the perfect design choice, but there are special requirements that general packages usually do not cover or cannot change easily. So in PAT, we have many action modifiers, which can modify different locomotions behaviors. These modifiers are used as a bridge between the locomotion and the skills. For example, as a user, we can easily make, the character ignores the gravity in a specific period of time or add some extra movement. So the implementation of these wild abilities does require some coding, but the lines are much fewer than we expected. In fact, it was even very surprising for us to find that the implementation took a much shorter time.
So that was for locomotion, and what about the combat? We recognize that there is a challenge on recreating the weapons that in Castlevania, and also there are restrictions on the locomotions. You cannot move while swinging the hammer, but the Cristic Ramp, or also known as Woman Way in different translations, is a signature weapon from Castlevania that has no effect on your movement. And what we want to see from this prototype is whether our system supports that. And the answer we had is yes. A Penguin Action Toolkit user can create the different weapons by using the native pad. And we still made some adjustment on it. So before, if you want to create different weapons, you will have to attach multiple scripts to one single game object. And you have to do that on every different weapon. And we introduced a new feature that helps developers to do that job faster and cleaner. We created a template for developers to bring in the individual components they need, and they now only need to change one big chunk template like that shown above. And with that combined script, you may create weapons that feels differently. And similarly, knockback is another problem. In most games, typically, there are two ways of knockbacks. You either attack someone, and there will always be a knockback animation, or all attacks don't have knockback at all. But in Castlevania, there is knockback, and it's only toward the players. So does Penguin Action Toolkit support that? Again, the answer is yes. In Penguin Action Toolkit, all the characters, including the ones controlled by the players and the ones controlled by the AIs, are all sharing the same structure. And the way they receive commands and how they respond to events should be very similar. So we could make this difference on knockback without changing any code in our existing framework. And we just pick some values, and it works. So the keyword from our prototype would be improved our modularity with the usage of templates. There is a basic template on both locomotion and combat. So you can make different designs depending on what you need. And that is how we pass the Castlevania test.
While this internal prototype experience can be seen as an internal playtest, we didn't forget to get playtests from external users. A first-year ETC student was invited to use our toolkit. We guide him with verbal step-by-step instruction, and luckily, he successfully reached some very interesting and unique game design within only 30 minutes. However, on the other hand, we do see that he's kind of struggled by the redundant inspector information sometimes, which is something we need to improve in the future. Apart from that, we also investigated some industry professionals in the progress to get feedback and inspirations. Zach loved our structure, and he thinks that some functionality like game data serialization will be a good addition, which is translating your game data into a sprite sheet so you can manage by designer. River, as an experienced combat developer, appreciated our work, while she also mentioned that tutorial is a lot more helpful than documentation for our case. Those are all very good feedbacks. That's kind of what we got right now. We have proven that our combat system is flexible enough to suit different type of design, while the needs of good inspector and good tutorial will be very helpful if we want this to be used by client efficiently. We are going to have more playtests either internally or externally. And in the progress, we will get more iteration on the code and tutorials.
So as we said, we know we need documentations, and how are we going to do that? So as someone who has struggled with Blueprint through the Unreal's documentation, maybe it's my fault, but it was a disaster. And we need a documentation that can help people understand what each script is doing and what should they change to make an action looks different. So we are in the process of making it, and we looked up how how the other toolkits are doing it. So this is Quirky Engine, and even though it's not an action game toolkit, it still has a very intuitive documentation that focuses on the details, and that's what we are going to do. We follow their pattern and had written the documentation for part of our systems. It does not only show you what are the APIs, it also includes explanations of how the structure was built of PAT and insights on how the components are related and how users may use different components for a better outcome.
So for tutorials, referring to other similar packages, we divide our functions into different chunks and provide users with sample scenes and demos with very detailed instructions. So usually users prefer getting hands-on experience first, and learning through practice builds a more manageable learning curve. So through our playtest, we found that a good learning curve for PAT would be from bottom to top, because if we try to introduce, well, the player or the character at first, there would be too many concepts engaged. So starting from a single action state with its modifiers, users can get a better understanding about how PAT works.
Our another effort to improve the usability is to create our own Unity editor called PAT Manager. The reason we made it is because the structure of an action game character is usually complex. The image on the left shows the structure of one of our character, and it's a pain to either create one from zero or to modify it through the developing process. In order to make the process easier, we made this GUI editor that can display the character structure as a node graph. It is then more intuitive to construct one from zero or to change some components without even knowing the whole character structure. We've also made convenient functions like character initialization, and we have also achieved the synchronicity between the node graph and the character associated with it.
So to further improve the usability of our toolkit, we decided to make some 3D assets used in both tutorial and simple scene to help users better understand the toolkit. So for the simple scene, we will mostly include at least a rig penguin model with animation, simple iceberg scene, and some more weapon models to show that users could use our toolkit to make lots of various attacks. For now, we already have a penguin model and one symbolic weapon model. So for the next step, we will most focus on completing the simple scene, which includes the following assets. And this is the model of the penguin with textures, like the symbol of our toolkit. So considering about the significant workload time, cost involved in creating animations, we originally planned to use the Mixmore or third-party animation for the character animation part in our toolkit. However, since we intend to publish the toolkit, using someone else's assets wouldn't be appropriate. So after some research, we found that other similar toolkits solve these problems by using online resources only for the demo, not including the animations in the actual package, which we think is pretty good. But we are still looking into that solution, so maybe this is one of our probable strategies.
Okay, so far we know PAT is powerful, we know it's flexible, but we can't know if it's easy to use unless we get it to users. So following the previous talks on usability, for our rest of the semester, we will be focusing on delivering the product and support our users. We will finish tutorials and the documentation that comes with them by the end of week 8 because we want to be on time to present ourselves to BVW round 4 teams. So first year students, if you're still listening, share this information with your class. We also want to be able to host a game jam near the end of the semester. And the end goal for this project has always been the same since the day we pitched it. We want to publish our package with tutorials, documentation, and samples to the public so that we are really helping developers out there and making their lives easier. And that is the end of our presentation. Thank you for listening. We're now ready for questions.
I'll caveat my question by saying I think you guys have a really strong direction. You know who your audience is and the problem space. You've defined that really well. But I think there needs to be more emphasis on testing and user studies. And I know you talked about that a little bit, but how can we push that further? How can you integrate testing and user studies more into the project throughout the, let's call it the project life cycle of the semester?
So you mean outside the project lifecycle? You mean after?
Outside the project team, yeah. I think you have to test on real users?
Well, I think that is definitely a problem that we need to face. I mean, it's not very easy to just say that there is a package and you should all use it. What we know is that we have to start by ourselves in internal playtests and then try to do the external playtests through the students as all around here who are also game developers. And I think so far one thing we have tried is that try to reach out to this game industry people to let them give feedbacks on it, even if they are not going to directly use the package to make any games that they want. It is certainly something that we are still trying to come up with a better solution than just say that we are only doing the playtests all around us. And yeah, I think that's a very fair question to ask.
Sorry, Mo and I always ask questions. I was going to ask, so you moved to Metroidvanias, which I think is a good genre to try to experiment with. The one thing that came up as I was watching it is a lot of special abilities in Metroidvanias involve manipulating the environment, particularly like destructible blocks, for example, is a big one, right? It's like in Metroid, there's blocks you can destroy with missiles and bombs and running fast and spark shine, and there's a lot of different things, right? And so I was wondering how would people integrate essentially your toolkit into things like level design, which are sort of outside of the scope of your project, as far as I understand?
That's a good question. Like, although we are not planning to include level design toolkit in our package, we do provide some interfaces or not technical interfaces to provide feature like that. For example, in our damage system, like we're not actually casting damage. Instead, we kind of mimic like Unreal's game ability system. So you are basically sending effect to your target, and that effect will contain some tag information. So if you read the API and attach a script to some obstacles, that they will detect the tag of the effect they receive. They can do something like only fire can melt ice, or only bomb can destroy stone, something like that. That definitely requires a little programming progress, but I believe like with a proper documentation and our target audience will be able to do that easily.
Thanks.
Yeah, and also our toolkit mainly focus on the combat system. So the core of this toolkit will be the character, not the level design toolkit, not the level design part. But we will leave space for our players to integrate their own level design with our character.
Oh, thank you for your presentation. I'm Jerry. I'm a first-year student who is interested in making ARPG. Your presentation is very attractive to me. I have a question about so also related to Jonathan's question. So I was wondering how this can integrate into my developer flow, like workflow, or so I would like to know that the dependencies of this project. So if I want to do I need to include any dependencies to my world or my enemies or anything in order to make them work? That kind, yeah.
So is for enemy, yes, like you probably want your enemy and player both to be a character of our system, because in our system, all characters, regardless is an enemy or player, they are all exactly the same structure. So it is possible to have a custom enemy class that interact with the player, but it will be a little bit hard. But for the world setting, no, you actually do not need to have something like our own game manager or level manager at all. All you need is just an extra player classes that controls a character you pick. And for other dependencies, our only dependencies are all Unity default integrated packages like input system and Cinemachine. So you don't need to say something like you have to get a third party POG in order to get our package to work.
That sounds like great news to me. Yeah. Sorry, one more thing to add. Is there any? Do you plan to add a feature to your toolkit? I know it sounds hard. That can help developers make new animations easier. Is there a feature like that?
Okay, we actually spend a lot of efforts around animation animation. Like we are not making something like you can animate your own animation in Unity, but at least you don't actually need to build a very complex animator in Unity anymore. Like we like you can simply we have a mod called animation montage, which will kind of mimic how montage works in Unreal if you set up the animator like properly. So in that component, you will get a list of all animation layers in the animator and the clip all in a drop down, so you can just select the animation you want to play in this state by drag and drop, which will install string comparison or animator parameters.
Gotcha. Thank you.
Nope. That's time. Thanks, team.
Thank you.
Hi, we're Team Beyond Touch. As you remember, last semester, we developed a social game on Apple Watch. The game was fun to play, players enjoy it, so we decided to productize it and publish it this semester. This is a social game on Apple Watch for a party size of 3 to 6 players. In this game, all players will play face-to-face, telling their own stories. Each player will receive a story prompt and get assigned to a role of either a truth teller or a lie teller. Then they will have the opportunity to question and interrogate each other based on the stories they heard. The goal for each player is to hide their identity as well as find out other players' identities. And here's the fun part. During this game, when the players are telling their stories or answering questions, other players get to see their heart rate. Imagine bluffing in the face, but your heart rate betrays you, or you secretly shake your leg while telling a truth to increase your heart rate to make other players think you are telling a lie. Something like that. We showcased this game at the Serious Play conference in Toronto this summer. During the showcase, many guests came and played our game. Some of them were strangers to each other, and they got to know each other quickly during this 10-minute gameplay. Some of them were already friends, and the game could get super spicy. One reason we believe why this game is so charming is that seeing each other's heart rate is like revealing some secrets deep inside each other. And this adds a unique layer to the communication between players. Many of the players asked to play another round or take this back home, which we identify as a good sign that we should probably productize it and publish it to the market. So, it is on the App Store. The first ever social game on Apple Watch. Please feel free to download it and take it home. Enjoy it with your friends, families, and also help us improve it. This is one of the biggest steps we've ever taken. And to achieve this goal, we put in way much more effort than we expected. And the journey was pretty fun. We'll definitely share that later. But before that, let's take a look at a roadmap we showed at the quarters. As you can see, we plan to productize and publish our first game on the App Store by the Halves. It was ambitious. We said that, and we did that. For the next half, we'll shift our focus into developing our next game, and which we will discuss in the last part of our presentation. Next, welcome our UI UX designers to share our stories along the way.
Okay, thanks, Da. And So to make sure we are having an engaging experience for our games that is ready for App Store release, so we rapidly prototype and also test out our flows throughout the design process and make iterations based on the player feedbacks. So first, diving into the game. Imagine you're an author agent and you have a secret watch. And as a secret agent, you should always stay calm, like even during bluffing, and even if your heart rate is revealed. So our Chosolai training is here to help you become an expert at staying cool. And for a strong product that is open to the public, it should be downloaded and played. So, which means players should be able to figure out how the game works throughout the game without our external help. And that's the reason, so before the game actually starts, we have a rule books on your phone that introduce each game stages and explain how heart rate is used throughout the game. And we don't expect our players to fully understand everything just from reading this, but at least just like a warm-up to get an idea like what to do throughout the game.
So to make our game even more engaging, we designed this avatar customization system, which allows each agent to choose their own cover and code name before they start training. This adds a layer of personalization as we want to make the experience feel more immersive and also unique for each player. And after agents got their cover and code name, the smartwatches will be activated, and the party will be start on the watch. So design watch interfaces is very different from designing phone screens. Apart from cooperating the limitations, we also need to think about how we can utilize the special capabilities of the watch. So here's an example. Before the mission starts, one agent needs to pull up like a room code in which the others will join. So to give the players a bit of freedom, or like saying a feeling of becoming secret agents, we actually designed experience to make the players feel like they are actually synchronizing the secret watches. So as you can see from the screen, players need to enter the same mission code on the watch using the digital crown to enter the same room. And starting the mission, each agent will get their own identity, either true teller or a liar.
And here is an iteration we made based on our players' feedback. Since we find that many players, they tend to just ignore the small button on the top right, which is a check mark, which we intend them to click to move on to the further stage. So we just make it larger and recognizable. And by everyone confirming their identity, it is time for the entire party to together select a question prompt for them to answer. But at this point, we found that players, they often assume that they will also need to keep this prompt hidden, just like their identity in the prior stage. And also, they may not realize that only the host can shuffle the prompt.
So we made some changes to foster more collaboration, interactions. So now the guests will see the instruction to choose a prompt along with the host name on their watch, so that they know that they can discuss and select the prompt together. And moving to the next stage, story time. Each agent will have 30 seconds to prepare their story based on the prompt. And then another 30 seconds to tell the story one by one. So at this stage, or say from this stage on, listeners can see the speaker's heart rate.
And here we found that actually players always forget what the prompt is because they are also sharing their own stories. So we add the story prompt also on their phone screen, so for easier reference.
So after everyone has shared their story, it's time for the question round, or as we like to call it, the interrogation time. So from now, each agent needs to start to prepare to answer questions from others about their own stories, while the heart rate is going to be revealed and also recorded and monitored by the secret watch. So to add attention to this phase, others can vote in real time by pressing the choose or the lie button on their watch, which also sends a haptic response to the speaker's watch.
Finally, the ranking will be revealed, and agents can check who they deceived successfully and who they got right during the voting time. And also, you can choose to replay it at this stage. And now let's welcome to our developers on story behind the scene.
Thank you, Iris and Ivy. All right. In the last semester, we have successfully developing this game on an Apple Watch Series 8 45mm model. However, we indeed made some assumptions about the UI, for example, the dimensions of the screen. To release this game on the App Store, we have to make sure that this game actually runs on every Apple Watch. Different models of Apple Watches have different dimensions. We have 38, 41, 44, 45, 49 millimeters of watch faces. With the introduction of Apple Watch Series 10 in this fall, it further introduced 42 and 46 millimeter specifications. Well, and similarly, the companion app on iPhone has the same issue. The way we used to get access to the screen size is by using the Swift UI component called Geometry Reader. It works good if we have a fixed size screen so that we can easily calculate offsets or size. However, it has several technical limitations, and most importantly, the design files on Figma from our artists will only support a single version of a certain model, so we ended up with working on another workflow. Instead of asking our artists to prepare an individual version for the same UI, we're using iPhone 13 mini as a reference size for the iPhone app. And whenever we need to do the scale, we decide to align with X dimension or Y dimension. Well, this is pretty similar as what Unity is doing. Now, whenever we need to align with a Figma file, we'll be able to read the dimension from the design files and simply multiply with the dimension with a universal scale. It will handle the UI responsiveness. And thanks to the global access of Swift UI, we will only need to define this universal scale once, and all of our programmers will be able to make this change.
Okay. Apart from the look, we also completely reworked the architecture on how different devices and players work with each other. So when the project started last semester, we tried to use the Firebase database functions directly on Apple Watch to synchronize states between players. But then Apple said that they removed the support for WebSocket protocol on Apple Watch. Yeah. So it is not feasible for our project anymore. And even if WebSocket does work on iPhone, it also becomes unreliable after a while when the phone went into sleep. So by the end of the last semester, we worked around these limitations by doing all the synchronization work at the game start when the phone is guaranteed to be awake. The timetable of each game phases is generated on the server and sent to each iPhone, and each iPhone then progresses through the game without communicating with others after the initial handshake. Although this iteration worked as a prototype, it has some limitation. It's hard to implement voting and skipping phases and interactions, and also because WebSocket functions also only work on iPhone, the player will have to keep their iPhone awake during the game, or else they cannot start again with their Apple Watch. This is why we decided to refactor it into a new design where we move all the gameplay logic into serverless functions and let the clients communicate with each other using HTTP requests. Apple Watch is capable of doing HTTP requests on their own, so iPhone is not needed to start a game. However, using these mechanics for real-time synchronization still has a problem because when the watch goes into sleep, the network performance is also throttled. Fortunately, there's a feature called extended runtime session, which is designed for long-time use cases such as meditation. By setting our app as a mindful app, we're able to perform reliable network requests even when the watch goes into sleep. We were a bit worried about not getting past the review because of this, but it went without any hassle, so I guess you can say we're officially a meditation app now. Yeah. So the new design is very great for us. It makes voting possible, and it makes displaying the result possible. And the synchronization is also more robust because server can now detect errors and broadcast the status to our clients. And finally, the database operations are now done by server instead of clients, so it's more safe, and we can do authentication easier if needed in the future. That's it for the first game.
Thank you, Shihong. As we mentioned earlier, we are also prototyping our second game, Other Fitness Training. It's a social fitness game that motivates players to engage in fitness challenges with each other. Let's look at some design goals. First, we want players to move around physically in this game. Second, we want to make this game asynchronous because although our back-end network architecture grants a stable connection. It does not support high update frequency, such as milliseconds. And finally, we want players to play this game without carrying their phones around. Well, during one of our discussions, we were talking about stockpile rock, paper, scissors, which is also known as 波波楚气, which is a well-known unofficial popular game among Chinese kids. And the core mechanic is that you can only defend or attack after stockpile qi energy. What if we transfer this game mechanic to a social fitness game? Players need to burn enough energies first to launch, defend, or attack. So the game we come up with is a asynchronous turn-based fitness battle. And first thing to do in this game is to work out to reach calorie goal. Once the calorie goal is launched, you can launch actions like attack or defend. And you need to wait other agents to finish these 2 steps. And once the turn is over, the game state will get updated, including scores and ranking. And it will go to the next turn. All right, and to summarize, it's a game for 4 to 8 players, and then it has flexible durations, including 3 hours, 1 day, or 1 week session. And then you can work out at any time during a turn on your own pace. And to wrap up the first half of the semester, we have published the first ever social game on Apple Watch, Other Agent, Truth or Lie. And then for the second half of the semester, we are going to develop and productize our second game, Other Fitness Training. And thank you. We are open to questions.
So if I understand the fitness game right, this is very asynchronous. Is that right? Yes. Okay, I think I understand that. And it's how many players at once?
The range is from 4 to 8 players. Yeah.
4 to 8 players, and it's asynchronous. Okay, no, that definitely helps me understand it. Okay. And while I'm hogging the microphone, when did you put the game out on the store?
You mean the first game?
Yeah.
A week ago.
How's it doing? Do you have any downloads?
Yes, we have over 30 downloads so far. And then, to be very honest, it's our first time like telling the public that we are published. Yeah. So everybody download it and help us improve it.
Okay,
yeah.
Thanks.
Yeah.
It has almost reached 1K impression right now, although we didn't tell anyone.
So we do have ways of reaching out to maybe a couple hundred playtesters who know ETC work. We can advertise that this app is out there. So let me know, and I will broadcast out more messages for you. A question about the app that's out there. I was a little confused about the voting because you were voting while there was maybe a 2-minute response going on, and I wasn't sure if I just am changing my vote of liar or truth, or if I'm saying first 10 seconds is a lie, next 10 seconds is a lie, next 10 seconds is truth, and so on. So I wasn't sure if I was serializing votes based on the time of response, which seems much more complicated than just changing my binary vote. Can you just explain the voting a little more?
Yeah, it's just one vote. And it will upload to the server once the countdown is over. Yeah.
Thing to add. So it depends on the size of the vote bar, as you saw. Like if the truth bar is taller than the lie bar, that means you are voting truth. And then, yeah, and vice versa. Yep. Mm-hmm.
But yeah, that is also absolutely something that we observed during the playtest, that maybe we should add another like 5-second stage to tell the people to confirm their voting. Yeah, hope that will help. Thank you.
Should we start? All right. Good afternoon, everyone. We're Pop Free Studio, the animation production team. So yeah, this is our team. And they are our instructors, John and Ruth, and our subject matter expert, Ricardo. We'll be go over project overview, progress update, and future plans. So we're making a 3D stereo animation with the story of old man who lost his wife and his magical journey through fantasy worlds. We're aiming to create a vibrant fantasy-filled world with motion capture animation and letting the audience to immerse into the 270-degree panoramic screen of the cavern. The length of the animation will be around 3 minutes, and our target audience will be probably around 8+ age and might be interested in immersive media. Our production is going around 3 key points: storytelling, motion capture, and visual effects. There are 3 key points we got from the quarter feedback. One key piece of feedback we received during the quarter was to make the most of the 270-degree cavern screen. We've been refining our approach to scene layouts and span of animation to ensure that the whole space is used effectively. And also, conveying emotion is also crucial. After getting this feedback, we pay more attention to the emotional connection between the old man and his wife and the audience. We incorporate more expressive dance moves and music to amplify the emotional connection and ensure the audience feels the impact of their journey. And also, bottom-up design. Another feedback we got from the quarter was bottom-up design. It means that we can think about what looks cool first and then design from that point. It really encourages us to think creatively about which visual elements would stand out and enhance our storytelling. We've been iterating our fantasy world with more magical and fantasy elements. There are also some challenges we're facing. So one is, unlike traditional screens, cavern screen has many limitations regarding camera moves and angles. Fast move and complex cuts might cause the disorientation feeling for the audience. That's why we decided to not use the camera movements that much. Instead, we use environments and animation to show our story. Another challenge is how do we smoothly transition between fantasy worlds? We're going to have 3 distinct fantasy worlds, which we didn't want them to feel abrupt or jarring for audience during the transitions. The solution we found is to combine VFX with minor camera movements so the transition will be smooth. And also to manage the scope with limited time, we use motion capture animation and also online assets to speed up our production process. Next, I'll hand it over to Sarah for progress update.
So next we'll be showing you an animatic with a block out of our character movement as we're still waiting to get our mocap data and implement it. So our animatic starts with a black screen and an iris that slowly expands on a toaster, where the toast will pop, and then we'll have some burnt toast. Our character Oliver will then take this toast over to the table, moving very slowly as he's experiencing grief and is very lonely, and he'll put the toast down at the table and kind of sigh and take some deep breaths, and then he continues over to the other side of the room where the radio is, so he'll play some music to break his lonely silence. There, he'll take a moment to connect with the music and look at the photos of his wife and the memories they have together on the wall, and these memories will then start being reenacted behind him with a VFX shader that'll make them look like memories. We'll see him proposing to her, we'll see them holding a newborn baby together, and something like he will fix her hair. Then we'll have a slight music shift to indicate that the next memory is different. The next memory will be just his wife alone, and this time they can actually interact. So it'll be a touching moment where he'll turn around, and they realize this and can reach out as they prepare to go into the next world, where the room will shift into our warp transition. So next we are entering our first fantasy world, the Toast Galaxy. Here they'll be dancing on different pieces of toast, both together and separating and then reuniting multiple times as they dance throughout the galaxy. In this world, there's a lot of hope and wonder and awe as they're falling into these memories together. Around the world, we see clouds made out of butter and slides that are jam, different types of jam, such as orange jam, raspberry jam, things that you would find on toast. This world environment is about 50% complete, while our kitchen environment is more around 80% complete. Here, as the music starts to pick up again, as we're getting ready to go to our next transition, they jump onto a toast together and we'll slide down the orange jam slide, almost like they're sledding or skiing, and the camera movement will go into a cloud to prepare us for our next transition. So next we are entering our orange juice forest, and the music here is a lot more playful and energetic, as this is the climax of our piece where they're experiencing the full connection and joy through this dance. Here they'll interact with the environment, going back and forth around the whole place. We'll have orange juice start raining, they'll kick oranges and dance through different puddles. We're also still experimenting with different VFX to put in both of our fantasy worlds to make them even more fantastical. Then we have our camera slowly transition upwards into a bird's eye view to prepare for our next transition back into the kitchen. So we have our match cut to a cup of orange juice, and we return to our characters Oliver and Margaret sitting at the table together. And then Margaret will slowly fade away, leaving Oliver alone again, but this time he's more content with the memories that they've experienced to get him through the day. So just to emphasize our emotion curve, we start at a low point with Oliver experiencing grief and loneliness, and then as they start going through the memories, we experience nostalgia and yearning, and as we enter the first fantasy world, there's this wonder and hope that the memories bring them, and then reaching the climax with the joy and connection of the dance, and then we have a bittersweet farewell as the memories fade away again, and we end at a higher point than the start with an acceptance and resolution as Oliver has gained the strength to continue on through his day with the memories he has.
And you guys already also noticed we have 3 major transitions in between the piece. The first one is the wormhole transition, the second one when we hit the cloud, and the third one when we come back up from the fantasy to the reality. And the reason behind it is because we want to take the advantage of the immersive nature of Cavern, where we want to give the audience just a right amount of dizziness, because this is especially when we get into and outside the imaginary world. And we landed on this after numerous testing of the camera angles and movements. Eventually, we found this middle ground of transitions to push the narrative further. You guys might also notice we have all the characters doing A-pose in the animatic. It's because the mocap is going to come along the way. So first of all, big thank to Justin in Campus Motion Capture Lab. He helped us to run through this whole pipeline of motion capture where we initially have the thoughts of the dancer, and then we read them, solve them in Vicon software into skeletons, and then retarget it in Maya, eventually port them into UE for render. And with the pipeline sorted out, we've got our first actual motion capture session last Friday, and it was really, really smooth. Big thank to, again, Brenda and Bhuvan, our amazing dancers from CMU Ballroom Club. They're amazing. We had multiple takes on all the scenes that we need. And also, because we're doing motion capture, we had the ability to rip the animations apart and remerge them and do all kinds of fun things to it. And this is how the data might look like in real time. You see we have animation curve on the right. We can always adjust things. And then you have a peak somewhere. If it glitches out, you can always remove that by a single click. And that's how our character map on it goes. Also, quick notes of motion capture. Keep in mind to have T-pose at the beginning of every capture session. Otherwise, it's really hard to target. And this is another test. Shout out to Richie, our classmates, that we also figured out this, how to have our face captured in real time as well. And implement that in the characters can be a little bit tricky, but we're going to look into that in the future. That's me making all kinds of faces. Anyway, we're going to hand over to Xun. Talk about that.
Character plays a fundamental role in our project. Since we don't have a character artist, we are using third-party assets, which is the best solution for us. By combining mocap data we just processed with a well-rigged character, we can produce better results compared to the traditional keyframe animation. With this approach, we can create more expressive animation that convey our intended emotions efficiently. We don't use the asset as they come. Instead, we create custom shaders to modify the asset to fit our needs. Here you can see Our Lady Margaret in various forms. We have the freedom to customize her to fit different parts of our stories. We also use third-party assets for our kitchen scenes to allow us to rapid prototyping and have more time to explore our creativity. Following the given storyboard, we made our first surrounded kitchen with a table on the center. However, this layout does not feel good in Cavern. It feels too big and soulless. Addressing earlier feedback, we quickly changed the room's layout. We compact the kitchens and include parts of the living room. This new layout makes the room smaller and cozier. This is our current versions. We made several adjustments based on suggestions we got. And finally, we decorate the room with photos and ornaments and made this room a warm and narrative-rich environment. This carefully crafted room is designed to show Oliver's personality and living conditions, which is an important part of our story. Next, we will have Bonnie to show us the fantasy world.
So entering the fantasy scene is the rising part of our story. The concept of Toad's Galaxy was inspired by our instructors. The high contrast of colors and hanging particles will set the tones for these surreal moments and differentiate from the daily kitchen scenes. And these are the imaginary objects we have in this world. The butter clouds, the orange gems slide, which will connect to the next fantasy world, and the floating toads that the character is going to dance on. To fully utilize the stereo vision of Cavern, we also have sets of different VFX for our environments. So first we'll start with large-scale neural-like environments and zoom into a local area to see the galaxy particles, and finally zoom into our wonderland of toasts. We also did a few tests on the clouds in this environment. So on the left, you can see the cloud bursting out, and we can also control the paths of the clouds, allowing more flexibilities to putting clouds in our worlds. Next, Lucy will talk about the Orange Juice Fantasy World.
So this is our second world, Orange Juice Forest. So having the same approach for the Toad's Galaxy, here we emphasize the fantasy feeling by making everything really big. So it's called a forest. This is how we're going to do for the forest part. First, we intentionally control the shape of the foliage using speed tree, and then we make cell-wise shaders for them in Unreal Engine. For other parts of the texture, we're going to incorporate different texture in an orange to make things even more fantasy and crazy. Also, it is worth mentioning that we want our characters to step into the paddles and splash the orange juice, so we are using simulated water instead of just water surface shader.
And for future plans, our next steps including implement the mocap data for animation and refine the animation, and also developing furthermore on the art and the VFX. And also we will compose and do the post-process during the last 2 weeks, the 12th and 13th. Thank you. And we're open to questions.
So the cavern can be used in different ways, and I'm just curious, are you having the viewers wear the glasses, and are they going to be standing or sitting in the center of the room and just up to 4 of them? Is that your intended use of the cavern?
Yes, we're using the stereotypical version of Cavern.
And are you pushing it in any way? Like, for example, you want viewers to look left and then look right and then look left again. I know Flow played with transitions where they'd get people to go from extreme right to extreme left. So maybe communicating and then testing some of those are things we can talk about as you plan for playtesting in the future. Are you planning to use
Yes,
270
we
degrees?
carefully planned the movements of the character and moving them left to the right, right to the left at different places in the camera.
I have a question. Did I miss it? Where are the storyboards? Do you have storyboards?
We do have a storyboard and in many versions, but we didn't include it in the presentation because we think this
video we have right now is the best way to show our storyline and everything combined together.
So I would think the storyboard would be the best way to communicate it, because the storyboard is like a living product that you constantly iterate on and give context to and update over the lives of the production. And then you slowly turn it into an animatic, but you got to show the storyboards so we know the story.
So for this question, we don't have a 2D artist or storyboard artist in our team. So we have done storyboards in the very beginning of the production line. And from that, we basically just iteration and fix stories for just along the way, and this was the storyboard. Okay.
Okay, I got you. Anyway, yeah, we do have storyboard in mind all on the way, but we just didn't show it because time limitation. Now that also playing the whole thing might be a little bit, because it's getting the whole piece together might be the priority at the moment. But storyboard definitely helps a lot along the way for sure.
How are you dealing with the curve in the cavern? Does it make the kitchen tables and stuff look bent? I guess is what I'm asking.
Yes, it will bend things, but we tested and it feels bent in a good way.
Oh yeah, also for the kitchen, our artist did a really interesting thing where we kind of bent the kitchen normally is a rectangle, but we kind of bend the two walls sideways, so some of the furniture on the side will display correctly in cavern, especially. It will be almost like you're at a counter, kind of sort of thing, yeah. Also, the corner is going to be matching the cavern's split point, so they won't be distracting as well. Yeah, you'll see it in cavern. Looks okay.
Time for one more? All right. Thank you, team.
Thank you.